All right, welcome back. This is video 2 of Introduction to Integration, the definite integral. Last time we talked about the idea of a summation notation, that sigma is the sum. And when we look at this, usually what we have is we have some counter. We've called this I, K, can be really anything you need it to be. So in this case, our counter starts at 1 and goes to some number n, whatever we want it to be. And then we put something in here, which is whatever it is we're adding up. So squiggly push sub I. So we'd be adding up squiggly push 1 plus squiggly push 2 plus squiggly push 3 plus ... all the way to squiggly push n. And that's what that notation means. Just add them all up. So I want to talk about a few properties of various summations. So the first one is, what if I take the sum from I equals 1 to n of some constant value? Well, for I equals 1, this is the constant value, plus for I equals 2, this is the constant value, plus for I equals 3, this is the constant value. And this is just going to keep going until I get to the very last one, which is when I equals n. So another way to look at this would, of course, be, instead of writing all the little arrows, to just say, well, I want C1, plus C2 plus C3 plus C4 ... plus Cn. Well, since they're all constants and since they're all the same value, I have n quantities of that constant. So the sum of a constant n times is just n times the constant. Secondly, let's look at what happens if I am adding up all of the values of some function that is a constant times a bunch of numbers. So again, we've got C times A1 plus C times A2 plus ... all the way to C times AN. And we can factor out all the values of C, and we get A1 plus A2 plus ... all the way to AN. But that's just C times the sum of I equals 1 to n of A sub I. So we've got constant sum, which just leads us to n times the constant. We've got the sum of a constant times something, which is just the constant times the sum. Let's look at number 3. Number 3, what if we have a sum from I equals 1 to n of two things, A sub I plus B sub I? Well, again, this is A1 plus B1 plus A2 plus B2 plus ... all the way to AN plus BN. Now, I can regroup these. I could just write this as A1 plus A2 plus ... plus A sub n plus B1 plus B2 plus ... plus B sub n. But this is the sum of the A's, and this is the sum of the B's, which means that this could just be written as sum from 1 to n of A sub I plus the sum from 1 to n of B sub I. All right. So a couple quick ones, which we won't necessarily need a whole lot, but they're useful and fun to look at. Useful and fun to look at. Let's look at the sum from I equals 1 to n of I squared. So that's 1 squared plus 2 squared plus, well, that wasn't the one I wanted to start with. Sorry. Let's just look at the I values. 1 plus 2 plus 3 plus ... plus n. Well, it turns out, and I'm not going to prove this today, but we could just actually do n times n plus 1 . Gosh, sorry, having trouble with my controls here. N times n plus 1 divided by 2. So if you just want to sum a string of numbers, you could just take the number of numbers that you have, the number of numbers plus 1, multiply them together, divide by 2. That will give you the sum of the string of numbers. Let's look at number 5. And this is the one I started, which is I squared, going from I equals 1 to I equals n. Well, this is 1 squared plus 2 squared plus 3 squared plus ... sum of the perfect squares. And what we get is that the sum of the perfect squares is n times n plus 1 times n plus, 2n plus 1. I get writing faster than I get looking up at my notes, all divided by 6. So there's a fourth rule. Here's a fifth rule, and I'll give you one more, and then we're going to stop this video and call it good, which is that the sum of I equals 1 to n of I cubed. So 1 cubed plus 2 cubed plus 3 cubed is equal to n squared times n plus 1 squared over 4. So how does this work in practice? Very quickly, if I want to take the sum from I equals 1 to 50 of 1 plus I squared, that's just going to be the sum from I equals 1 to 50 of 1 plus the sum from I equals 1 to 50 of I squared. Well, this is 50 times 1. And this is, using my squared rule, 50 times 51 times 101, 2 times 50 plus 1, all divided by 6. And I can plug that into my calculator and I get some number. Instead of having to add up 1 plus 1 squared plus 1 plus 2 squared plus ... which very quickly gets boring and tedious. All right, so my recommendation would be to go back through this video. If you haven't been all the shortcuts that I highlighted, go ahead and jot those into your notes, and we'll be back with video 3. Thanks for watching.